about momentum. Come with me and look at more in-depth look at how this all works. By the way, this video is not shot.
The beat nagle, 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 the beat nagle. Trust me, we ain't gon' stop. Head to the lights up, watch us take over the spot. The beat nagle. Trust me, we ain't gon' stop. Head to the lights up, watch us take over the spot.
Brett, if you had to guess what momentum actually is, what would it be?
I would say it has something to do with objects that are moving. I'm not really quite sure.
You're actually somewhat right. Momentum is defined as the product of mass and velocity, or simply the force or speed of movement. It refers to the quantity of motion that an object has. To put it simply, if an object is in motion, it has momentum.
Oh wow, that makes sense. Thank you.
Do you have an idea what the formula for momentum is, Trent?
I don't know the exact variables, but sounds like object in motion usually have mass, and all objects have mass. And then all objects are usually moving too, with velocity. Alright, repeat it.
No, keep going.
No, that's right. That's actually right. That's right. Momentum equals mass times velocity, also known as P equals mv. The unit for momentum is kg times meters per second, and Isaac Newton was the person that discovered momentum. Let's look at an example of momentum.
Starts recording and press it again and stops.
Momentum is the change in velocity, and it has its own equation. In this equation, P equals m times v. P equals momentum, m equals mass, and v equals velocity.
Go.
The mass of the pool ball is 0.17 kilograms, traveling at a velocity of 5 meters per second. These two variables, we're able to find the momentum. Using the mass of the cue ball, which is 0.17 kilograms, and the velocity it was traveling at, which is 5 meters per second, we can plug it into the equation to find momentum. Simply, plug in 0.17 kilograms per mass and multiply that times 5 meters per second. As a result, you get 0.85 kilograms per meter per second for your momentum. Hey Raph, if you had to guess what impulse was, what would it be? Does it have to do something with momentum? Am I right? You are. Impulse is usually a change in momentum. It's defined as a change in momentum of a body as a result of a force acting upon it for a short period of time. Do you happen to know what the formula is? No. Now, alright, well I'll explain it. The formula for impulse is J equals F times T, where F equals force and T equals time. Here, we're going to show a prime example of impulse. As Raph pushes the car, as you push the car, impulse occurs because the velocity is changing, because of a force acting upon it. Understand? Okay. You're such an idiot. Go. Come on. Go. Push you. He's going to have a prolapse. He's going. No, come on.
Come on, Raph.
Use this. I don't care how dirty this is. What? This is an example of impulse! Go. Moving a car, stop to rest.
That's a cut. Bastard.
So much cooler in here.
Jace, a collision occurs when two or more objects hit each other. When an object collides with another object, each object feels a force for a short time. The two types of collisions are elastic and inelastic. An elastic collision is where two objects collide, and the total kinetic energy after the collision is equal to the total kinetic energy before the collision. Inelastic collision is similar to elastic, but kinetic energy is not conserved. That's a cut. Just some random.
fun zone. Go faster. Zach. Using the cue ball and the 6 ball, both having a mass of 0.17 kilograms, I'm going to show an elastic collision. The cue ball will be moving at a velocity of 5 meters per second, while the green ball is at rest with a velocity of 0 meters per second. The cue ball hits the green ball, and we can use the formula m1 times v1 plus m2 times v2 equals m1 times v1 plus m2 times v2 to solve for the ending velocity. After the cue ball hits the green ball, it goes from a velocity of 5 meters per second to 2 meters per second. Using the formula for elastic collisions, we can solve for velocity 2. Using the equation to solve for elastic collisions, we can plug in the mass of 0.17 kilograms times 5 meters per second plus 0.17 times 0, which is all set equal to 0.17 times 2 meters per second plus 0.17 times v2. After that process is done, you can take 0.85, which is 0.75 times 5, and set that equal to 0.34 plus 0.17 v2. Then you subtract 0.34 from 0.85 and you get 0.51 is equal to 0.17 v2. As an ending result, when you divide, you get 3 meters per second as your ending.
This is a diagram of what happens during the collision.
Now, during the collision, the cue ball is hit into the 6 ball, forming a collision right here. After the collision takes place, the cue ball will slow down from its original velocity, but making the 6 ball speed up in the direction it is hit towards.
This is Jason. That's Raph. That's Mike. I'm so confused. What is I'm not a star. Somebody lied, I got a chopper in the car, so don't make it come alive.
Yeah.
Rip your bar, then I pull myself together. YMCMB, double M, we rich forever. The bigger the bullet, the more that gon' bang. Red on the wall, Basquiat when I paint. Red Lamborghini.
The mass of the pool ball is 0.17 meters per second, traveling at a velocity. Wow, I fucked up. After the cue ball hits the green 6 ball, it is moving at a velocity of 2 meters per second, changing.
Yeah.